Last spring, I mixed about $1 worth of powder from my pantry into a 5-gallon bucket of water, poured it around the base of 3 tomato plants, and pulled 45 pounds of fruit off them by September. No Miracle Grow, no fish emulsion, no bone meal. Just a mix the USDA itself recommended in a 1943 Victory Garden Bulletin, and then quietly pulled from circulation in 1968 after the EPA took a closer look at one of the ingredients. I tested it for 2 seasons in my test bed against a 5, 10, 15 commercial feed. The Pantry mix won both years. Stay with me to the end because I'm also going to tell you the one ingredient I now leave out of the original 1943 recipe and the cheap substitute I use instead that works even better. Here is what happened. In the spring of 1943, the USDA Office of War Information, working through what was then called the War Food Administration, started publishing a series of Victory Garden leaflets aimed at home front food production. Commercial fertilizer was being rationed. Synthetic nitrogen was being diverted into munitions and into large-scale grain production. For the troops, home gardeners could not buy what they were used to buying. So the USDA did something it has not done since at any meaningful scale. It taught people how to make effective fertilizer out of pantry staples. I found a scanned copy of one of those leaflets in the Iowa State Extension Digital Archive about 3 winters ago. The recipe is plain. 6 ingredients, all of them sitting in a 1943 kitchen, mixed into water and poured around the root zone. The leaflet ran the calculations. It worked. Home gardens produced an estimated 40% of the fresh vegetables consumed in the United States during the war years, and a significant amount of that yield came off pantry mixed soil. Then the war ended. The Haber-Bosch nitrogen plants that had been making ammonia for munitions were converted to civilian fertilizer production almost overnight. There was suddenly enormous synthetic capacity looking for a domestic market. And the Extension Service, increasingly funded through partnerships with the agricultural input industry, slowly stopped reprinting the wartime bulletins. By 1968, after federal regulators flagged one specific ingredient in mid-1960s runoff studies, the USDA quietly let the bulletin series go out of print and never replaced it. An estimated 20 million home gardens shifted over the next 2 decades from a $1 pantry recipe to a $40 bag of commercial feed. That is the trade. That is what was lost. Let me give you the recipe first. Then I will walk you through why each ingredient is in there. Then I will show you the test data. And then I will tell you the part that even people who have heard of this mix do not usually understand. Per 5 gallons of water, you need 2 tablespoons of Epsom salt, 1/4 cup of non-fat powdered milk, 1/2 cup of wood ash sifted through a kitchen strainer, 1 tablespoon of unsulfured molasses, 1 teaspoon of baking soda, and in the original 1943 version, 1 teaspoon of borax. That is it. Stir until the powders dissolve. The wood ash will not fully dissolve. That is normal. The potassium leaches into the water and you pour the slurry through. Application rate, 1 quart per plant at transplant. Repeat 1 quart per plant when you see the first flower. Third application, 1 quart per plant at first fruit set. That is the entire feeding schedule for the season on tomatoes, peppers, squash, and most fruiting vegetables. 3 applications, about 15 cents of materials per plant for the year. And that is exactly the kind of recipe you will not find printed in any modern extension pamphlet. Because the modern extension pamphlet was written after the bulletins it replaced went out of circulation. Here is the science. Each ingredient is doing a specific job, and they are doing those jobs together in a way that commercial feed cannot replicate. The Epsom salt is magnesium sulfate. Magnesium sits at the center of the chlorophyll molecule. Every leaf needs it. Most clay soils in the eastern United States, including my Black Mountain clay, are low in available magnesium because it leaches out over time. 2 tablespoons in 5 gallons gives you a small, steady dose right at the root. The powdered milk is doing 2 things at once. The calcium is the obvious one. And calcium uptake, what I mean by that is the plant's ability to actually move calcium into new fruit at the moment of fruit set is probably the single most undertreated nutrient issue in home gardens. Powdered milk delivers calcium in a slow-release form bound to milk proteins, which the soil microbes break apart over a few weeks. The second job is the lactose. Lactose is a sugar. Soil bacteria feed on it. You are not just feeding the plant, You are feeding the workforce that feeds the plant. The wood ash is your potassium source. Potassium drives sugar transport. It is what moves the sugars the leaves make down into the fruit. Higher potassium availability means higher Brix, which is the sugar reading on a refractometer, which translates to better flavour and longer shelf life on the fruit. A half cup of hardwood ash carries roughly the potassium of a commercial application, without the chloride that comes with muriate of potash. The unsulfured molasses is carbon for the soil microbes. The same microbes that feed on the lactose go after the molasses sugars even more aggressively. And when you grow a healthy bacterial and fungal population in the root zone, those organisms solubilize phosphorus. They unlock the phosphorus that is already in your soil, bound up in forms the plant cannot directly use. Most soils have plenty of phosphorus. The plants just cannot reach it. The molasses changes that. The baking soda is a small thing, 1 teaspoon in 5 gallons. It mildly raises the pH of the solution at the root zone for a short window after application. Long enough to improve calcium uptake during the absorption period, it is not a long-term pH amendment. It is a brief assist. And the borax in the original 1943 recipe was a boron source. Boron is a micronutrient needed in tiny amounts, but essential for cell wall formation and pollen viability. We will come back to borax. There is a reason I do not use it anymore, and that is the whole second half of this video. That is the chemistry. Calcium, magnesium, potassium, phosphorus released through microbial activity, a carbon source to feed those microbes, a small pH bump, and a micronutrient. 6 ingredients. Most of the work is not being done by the ingredients directly, only it is being done by the soil biology the ingredients support, which is precisely the problem if you are selling fertilizer by the bag, because a bag of synthetic feed bypasses the soil entirely and delivers nutrients straight into the plant. The plant grows, the soil does not. Now the test data. I ran this for 2 seasons in my test bed, which is the 4x8 bed near the deck where I do side-by-side comparisons. Year 1, 3 Brandywine plants on the Pantry mix, 3 Brandywine plants on a commercial 5 or 10, 15 liquid feed applied at the manufacturer's recommended rate. Same soil, same drip schedule, same pruning. The only variable was the feed. Pantry mix row averaged 38 pounds per plant. Commercial 5 or 10 by 15 row averaged 24 pounds per plant. That is a 14 pound per plant difference on the same variety in the same bed. I weighed it. The notebook has the entries. I ran the Brix readings on the fruit because yield is one thing and flavor is another. Pantry mix fruit averaged 5.8 Brix. Commercial feed fruit averaged 4.6 Brix. Translated, that means the Pantry mix tomatoes had measurably more sugar, denser flavor, sweeter eating, better shelf life. The plant was moving more energy into the fruit, not just making more fruit. Year 2, I replicated with Cherokee Purple because I wanted to make sure it was not a Brandywine specific result. Pantry mix, 41 pounds per plant. Commercial 5, 10, 15, 27 pounds per plant. Same direction, slightly bigger spread. And that is when I stopped using commercial liquid feed on my main tomato beds entirely. The notebook does not lie. The fruit on the scale does not lie. 2 seasons of clean comparison was enough. Now here is the part that surprised me. And this is the layer most people miss, even when they have heard of the Pantry mix. The standard explanation is that the Pantry mix delivers nutrients more gently than commercial feed. That is not really the whole story. The whole story is what happens to the bed over multiple seasons. Commercial liquid feed delivers nutrients directly to the plant's roots. The plant absorbs them, but the soil microbiology gets bypassed entirely because the plant does not need to ask the microbes for anything. The feed is already in solution, already in a form the roots can take. Over time, in a bed fed only on commercial liquid, the microbial population thins out. Cation exchange capacity drops, which means how well the soil can hold onto nutrients without letting them wash away. The bed gets weaker each year. You compensate by feeding more. The Pantry mix does the opposite. The molasses and the lactose feed the microbes. The microbes solubilize the locked phosphorus. build the soil structure, hold on to the nutrients between rain events. Each season, the bed gets stronger because the microbial workforce is being fed. My records show that by the third year on the Pantry mix, the same bed needed about half the application volume to produce the same yield. The soil ecosystem was doing more of the work. That is the part the commercial feed model cannot replicate, because the commercial feed model is built on selling you more product next year. A self-strengthening soil is bad for the bag fertilizer business. And that is why you will not find a soil microbe first feeding philosophy in any extension pamphlet sponsored by an agricultural input partnership. All right, let us keep going. Before I get into why this recipe got pulled from circulation in the first place, I want to share something with you. If you're already gardening, but you know you are underperforming, if what I'm walking you through here is making sense, and you want the full feeding schedule, not just this one mix, that is laid out day by day in Chapter 5 of my book. The chapter is called The Three-Phase Feeding Calendar. It walks through what to apply at establishment, at flowering, and at fruiting, with the timing triggers and a diagram showing the whole timeline from transplant to final harvest. The book is called Steve's 30-Day Maximum Yield Protocol, $17 at stevesgardenbooks.com. If you're watching on your television, grab your phone and point it at the QR code on screen. If you're on a phone or laptop, the link is in the description. Take your time pulling that up. No rush. I will be right here when you get back. All right, let us keep going. So why did this recipe disappear? Here's the part the standard story leaves out. The ingredient that got the recipe in trouble was not the powdered milk, not the wood ash, not the molasses. It was the borax. 1 teaspoon of borax in the original 1943 formula, sodium tetraborate, and in the mid-1960s, federal regulators, this is before the EPA was formally established in 1970, so this was the precursor agencies handling agricultural runoff, began publishing studies on borat accumulation in soil and surface water. They were not wrong to look at it. Boron is one of those micronutrients where the gap between not enough and too much is very narrow. In excess, it builds up. It can run off into waterways. The science on that was real, and I want to be honest with you about that. Here is what is interesting, though. The regulators flagged 1 ingredient out of 6. The recipe was, by any honest reading, 90% good and 10% in need of a swap. And in 1968, the USDA had a choice. They could have reprinted the bulletin with a corrected version. Drop the borax, recommend a safer boron source. Keep teaching home gardeners how to feed their plants for $1 a season. That is what a public agency in the business of helping home gardeners would do. They did not. They quietly stopped reprinting the Victory Garden bulletins. Extension officers were given updated guidance that pointed to commercial fertilizer products instead. And by then, the post-war synthetic fertilizer industry had scaled up. The same Haber-Bosch capacity that had been making munitions during the war was now making bagged fertilizer for civilian sale. Extension officers were increasingly partnered with industry. Nobody had to write a memo. The recipe just fell off the page. And here is where it lands on you. A generation of home gardeners spent 40 years buying $40 bags of fertilizer they could have mixed for $1 in their kitchen. 20 million home gardens, give or take, every season. They did not tell you the recipe was 90% good and 10% needed a swap. They just stopped telling you the recipe existed. Which brings me to the bonus I promised you at the start. The ingredient I now leave out of the original 1943 recipe is the borax. The regulators had a point about that one. And the substitute I use instead is 1 extra tablespoon of unsulfured blackstrap molasses, bringing the total to 2 tablespoons per 5-gallon batch. Costs about 15 cents. Here is the science. Blackstrap molasses naturally contains trace boron, small amounts, well below any accumulation concern. And more importantly, the carbon in the molasses feeds the soil microbes that solubilize whatever boron is already locked up in your existing soil. So you get the boron benefit through the biology, not through a concentrated dose. I ran the comparison, 2 seasons in the test bed, borax version on one row, molasses substitute version on the other, same variety, same water, same everything else. What I found was the molasses version matched the borax version in year 1 and slightly exceeded it in year 2. And there was one other thing. The borax version occasionally caused leaf tip burn During the dry stretches in August, when the soil moisture dropped and the core boron concentration spiked at the root zone. The molasses version never burned a single leaf. The fix was never field tested by the USDA because the recipe was pulled from circulation before anyone got the chance to revise it. All right, before I let you go, if you want to understand the chemistry underneath all of this, why pH matters for calcium uptake, how nutrient availability shifts across the soil pH range, what each micronutrient is actually doing in the plant, that is chapter 3 of the book. It is called Soil Reset, the Chemistry of Fertility. There are line art diagrams in that chapter showing soil nutrient availability across the pH range and the compost layering cross-section I use for my own beds. If you are the kind of gardener who wants specific numbers, not vague advice, that chapter is built for you. 115 pages, $17 at stevesgardenbooks.com. If you're on the television, point your phone at the QR code on screen. If you're on a phone or laptop, the link is in the description. Take a second to pull that up. No rush, I will wait. So that is the 1943 pantry recipe, and that is the one ingredient swap. Borax out, an extra spoon of blackstrap molasses in, that the Bulletin never got the chance to publish. Now you have a $1 fertilizer system the industry spent 50 years not telling you about. Next time around, I'm going to walk you through a 1950s home soil test method that, in my test bed, outperformed the modern lab panel I sent samples to. Your conditions might be different, so test it on a single plant before you commit the whole bed. All right, that is what I have for you today. I will see you in the next one.